Hi all. Hope all of you can hear me well. Can someone please ping? Okay, great. Okay, great. Yeah. So thanks for joining in, and I hope all of you are doing good and staying safe. I'm Prabhas Srivadana from WSO2, and I've been with the company for almost 13 years now, and mostly working on building the WSO2 identity service, an open source identity and access management product. If you are new to WSO2, we have a set of open source products. In addition to the identity server, we have an API manager and also an enterprise integrator. So this is our second meetup under the IAM for application developers meetup group. The first one we did last week on JWT, and so we plan to do meetup every week. So next week we plan to do a one on O2O internals and applications. A couple of housekeeping items before we start. So all of you are muted. So in case you have any questions, you can just ask it in the Zoom chat, or else you can unmute and speak up as well. Okay, so so this session today is about securing a set of microservices deployed in Kubernetes with Istio service mesh. So we assume that you have a good understanding about Kubernetes and also some level of understanding on Istio service mesh. So that means we are not going to cover like basics around those technologies. And so there are two parts in this presentation, this session. First, I'll take you through some of the patterns in a platform agnostic manner, how you can use those patterns to secure microservices and how things evolve. And second part of the session, we'll see how to implement those patterns with Istio. So that's the plan. And once again, if you have any question at any point, please feel free to raise. Okay. So in terms of security in a typical microservices deployment, we worry about two policy enforcement points. Right? So one is at the edge, and the other one is between services in service communication. Or else we need to have a policy enforcement point or security checkpoint for all the north-south communications. And also we need to have a set of policy enforcement points for east-west communication, that's service-to-service communications. Most of the time in a typical microservices deployment, you will see an API gateway which fronts all your microservices and selectively will expose a set of microservices to the outside world, so the client applications can consume this. So you don't need to expose everything out. You can selectively pick which microservice you want to expose, and then so the client applications can talk to them. So who are the audiences of a microservice exposed on API gateway? Most of the time, it's a system accessing a microservice via an API just by being itself, or else a system accessing a microservice via an API on behalf of someone else, a user. In this, but if you look at this particular slide, so you have a single page app, a mobile app, then a web application. So if you take the use case where a system accessing an API on behalf of an end user, then you will have an identity provider, probably it's supporting OpenID Connect. So users will go to OpenID Connect identity provider and come back to the service provider or the application with an ID token. Then the application will invoke an API on behalf of the user following the OAuth protocol. So OAuth has become the de facto standard for securing APIs. So when the request hits the gateway, gateway will intercept all the requests and then extract out the access token and will talk to its trusted IDP or the security token service and validate the token. Most of the time, an API gateway will be attached to a single trusted SDS. And if you want to onboard multiple IDPs, so there can be multiple trusted IDPs too, but that trust brokering will happen via the SDS. So the gateway will always trust one SDS. So once a token is validated, so a gateway knows it's a legitimate request, and it will then dispatch the request to the upstream microservices. And also when you pass that request, it will also pass some user context or application context to the upstream microservices. So the microservice itself can use that data to make authorization decisions. Once again, like if you go to a little bit of detail, the token that you get from the application, it's an access token. So it can be a reference token or else a self-contained token. So if it's a reference token, then the gateway always has to talk to the issuer of the token to validate it. But if it's a self-contained token, so that means a JWT, you can just validate it with the corresponding public key. So basically, first you need to establish trust between the issuer. Then you don't need to. Since then, you don't need to talk to the issuer to validate a token. You can do it by yourself. Okay. Now let's have a look at some of the patterns we see in securing service-service communication, which is once again the most important aspect in securing a microservice deployment. And it's a little bit challenging too, because to pick the security protocols you want to secure the service-service communication all depends on what level of, like, what sort of protocols you pick. It can be HTTP, gRPC, or you can use even eventing mechanism for the communication between microservices. So this is the most common pattern we see among the companies who are new to microservices, right? So we've been talking about microservices for a long time now, but only in the last couple of years, we have started to notice that there are real production-ready microservice deployments. Right? So now people are taking this seriously. But even though people take this seriously, so initially they worry about getting things up and running. So they worry about getting the deployment up and running and covering the functional requirements. So when you worry too much about functional requirements, you don't worry that much about non-functional requirements like security. They just want to get the security done to some level. So that's why many people who are moving to microservices, the service communication, they simply trust the network. So the gateway will intercept the request and then dispatch it to the microservices deployment, and they simply trust the network from there on. So this is not a good pattern, but we see this is the place people get started. Right. So what we see today is like when you mature in your microservice deployment, you mostly go to a zero trust network pattern, especially if you use a service mesh that helps you to build this zero trust network pattern in securing your microservice deployment. Okay, so the next improvement to the first pattern, the trusted network pattern, so earlier, like, you were using TLS between microservices and from the gateway to the microservice. Now you will do one improvement there. You will use MTLS or enforce MTLS between the gateway and the microservices, and also among microservices. So here you add another level of security, you not just simply trust the network, you also authenticate the workloads when they talk to each other. Still, there's a challenge. So, so when you have MTLS, it will authenticate the workloads, but how do you pass the user context from the gateway to the upstream microservices? In this particular pattern, the way it happens is, so once the gateway validates the access token it gets from the application, which carries the user context, it simply pass that token, whatever the parameters, as HTTP headers to the microservices, and they will get that and then use those headers, and also pass those headers to other microservices data. For example, the header comes to this microservice and it will use it, and then again when it goes to another microservice, another upstream microservice, it will pass that header. So there's an obvious issue here. That is, when you just pass those headers as HTTP parameters, there's no way to protect the integrity of those headers, right? So if there's a microservice, this particular microservice can change the headers and pass it to the other microservice, there's no way the second microservice can figure out these header parameters being nulled, right? So there's an issue here. So even though you have mutual TLS, there's still a level of trust on the network. Okay, to overcome that, what we can do is, you have MTLS between workloads, the gateway will embed the user context into a JWT, a JOT, which is signed by its STS, which is also being trusted by all the workloads in your microservice deployment, and then pass that JOT along with the request to the microservice. And the first microservice, when it talks to second microservice, it will also pass the same JOT, right? So this will address the first concerns. Now the integrity of the token is protected, but still there's an issue. So you can treat this particular JOT, JWT, as also as a capability token. That means just having a JWT will also get access, or you will inherit a level of privileges. In this case, since you're sharing the same JOT across microservices, then the audience of the JOT, so when you have a JOT, JWT, it has an audience, right? So audience means the recipient of, the legitimate recipient of this particular token. Since there's a shared token, all the microservices are recipient of this JOT. So if this JOT carries a level set of privileges, then all the microservices will use it, or can use a JOT to access those services. So that's one issue in this pattern. To overcome this pattern, what you can do is, so like in the previous case, you generate a JOT and send it to the first microservice. And when the first microservice wants to talk to the second microservice, it won't simply pass the original JOT it got from the gateway. It will exchange that to a new JOT. You talk to the STS, the issuer JOT, and get a new JOT and pass that JOT to the second microservice. Now the first JOT has the audience pointing to the first microservice, and the second JOT has an audience pointing to the second microservice. This is a very much improved pattern from the previous one. So now, how do we implement that, right? So there are multiple ways you can implement that. So one basic principle in microservices is the single responsibility principle. So your microservice implementation should not do anything more than what it's supposed to do. So especially you should not worry about implementing security stuff in your code itself. But if you take Spring Boot, for example, right? Spring Boot has a set of handlers which can do OAuth, JWT validation, and some like authorization checks, security validation. So even though those are reusable components outside your business logic, you can simply embed those handlers to your business logic. Still, it's in your process. So we call this pattern as an in-process service mesh, right? So you have the proxy, but it's part of your process itself, right? The other one is out-of-process service mesh. So that means you decouple this secret processing or the code to handle these non-functional requirements, and you deploy it outside your process. And so the benefit is these components can evolve by itself, can be developed in multiple languages, and can be reused across different microservices. So now each microservice will have its own proxy, which will do this security validation. So you get MTLS, then MTLS handshake will be handled by the proxy. And when you get a JOT validation will be done by this proxy. So this is one way of implementing the zero trust network pattern. So when it comes to zero trust network, so that means you don't trust the network. So if you don't trust the network, what should we do? We should make sure we do all security checks, security validations as much as closer to the resource, right? So in this case, what's our resource? It's the microservice. So you have a proxy, or you can call it as a policy enforcement point, as much as closer to the microservice, and do all security check validations, right? So in practice, both the proxy and the microservice will run on the same machine, okay? Yeah, so this, what you can see in blue, we can call it as a data plane. All the runtime traffic will go through the data plane, right? So any request coming to a microservice will go to the proxy. At the same time, any response or any other request generated from the microservice, that will also go through the proxy. So this is the data plane. And then, so to define policies that has to be enforced at each proxy or the policy enforcement point running in the data plane, you will also have a control plane, right? So control plane can do certificate management, then define authorization policies, like capture telemetric data, and then define routing rules. So basically, you can define control instructions at the control plane and push them into the data plane. So those will be enforced by the proxies. So this is the service mesh pattern we see. So now when it comes to authorization, we see two main patterns. So one is the call home pattern. The other one is the embedded PDP pattern. So when it comes to the call home pattern, so you have the proxy, which intercepts all the requests coming to your microservice, and it will intercept the request, extract out certain parameters. It can be JOT or with somehow by validation token or somehow it extract out the data, and then it will generate an authorization request and call to the PDP, policy decision point running in the control plane. Then PDP will have set of authorization modules. It can connect to external policy engines and somehow evaluate the decision and send back. If it is permitted, then you are allowed to access the microservice. That's the call home pattern. We see this is a common implementation. The issue here is you always need to do a remote call. It's not like self-contained. Now the other one is embedded PDP pattern. So you have the policy decision point embedded into a microservice or co-located with your microservice. All the policies are there. So whenever request comes, the same proxy will intercept the request, generate the authorization request, but instead of going to the control plane, you will talk to your own embedded PDP and authorize the request. Right? Then if it is permitted, then you will let the request access your microservice. So this pattern has its own overheads too. So you need to worry about how you provision policies, then how you update policies in the PDP. So most of the time, like when you have this pattern, you will also have a policy administration point, a PAP running in the control plane. So it knows how to propagate these policy update decisions to the embedded PDPs. Okay, so that's the first part which I wanted to finish in a small amount of time. If you have any questions, I can take them now before I go to the next session. So next session would be like more hands-on session. Okay, so we discussed about the service mesh pattern. So Istio is an implementation of the service mesh pattern. Yeah, so there's one question. Is a PDP specific to microservice or generic? Its PDP is generic, so it can be any PDP. Yeah, yes. So there's no specific specifics related to microservices. It's any PDP. So it can be like, for example, OPA is a very popular PDP in the microservice deployment. But OPA is once again it's not only about microservice. It can be used for any to do any access control decisions. Yeah, so the question is, what about service specific policies? Yeah, so if you look at the first slide, so there are two policy enforcement points. The gateway itself is a policy enforcement point. So you will have organization level policies enforced at the gateway level. Then the proxy here running co-located the microservice will do the service level policy enforcement points. Okay. Okay. Yeah. So this is a high level architecture of Istio. So I won't go through all the details. So here you can see the data plane. In data plane, you will have the Istio ingress gateway, ingress proxy, which is an envoy proxy. Then you have the service proxy. In a Kubernetes deployment, you have pod, then you have your microservices, and then the envoy proxy, and then you have the egress proxy. So all the requests coming to the Istio deployment comes to the ingress proxy or the ingress gateway. Then all the requests will be intercepted by the service proxy before being dispatched to the corresponding service. And if you want to talk to an external service, those requests will go through the egress proxy. Once again, it's not a must. If you want to skip the egress proxy, when you generate a request within a service, you can do that as well. Okay? So Citadel is the one who takes care of provisioning identities to each workload and also keep managing those, right? So Mixer has a very flexible plugin architecture. So you can have authorization plugins, then plugins to take care of telemetry data, then do quota management with Mixer plugins. Okay, so now, so this is the use case we are going to implement. We'll do this step by step. So I have order processing microservice and an inventory microservice. So this microservice ideally should be protected with OAuth, right? So you need to access this microservice, you need to bring JWT, and you send a request here. You can do a get and view the orders. And also when you post an order here, so you authenticate with JOT and post an order to the order processing microservice. Then order processing microservice will send another post to inventory service to update it, or do a put to inventory service to update the inventory, right? So this communication once again should be protected with mutual TLS, and also the end user context will go in the JOT, right? So the end users who will access this microservice first will log into a web app using OpenID Connect, and you get an access token, a JOT token from this secret token service. So we are using curl here. Then using that JOT token, you access the order processing microservice. Any question on the deployment before we go into the implementation? Okay. So let's see how to do the deployment. Okay. So this is my deployment of the order processing microservice. So I won't go through this in detail, right? And then the inventory microservice, and also the STS. Okay. So let me create the deployment first. So I'll create the STS. I think I have created this already. And then I'll create the order processing microservice, and then the inventory microservice. Okay. Now let's see what are the available services. So now you can see the inventory service, order service, and STS service all available. So I use a node port type here. You don't need to use node port type. You can just use the plus type here, because before we go into the advanced use cases, I want to show you how to invoke this without any security, and just to see whether how it works, right? So if you go to slides, here I'll do a curl to the secret token service and get a access token, which is a self-contained access token, right? So here the application ID and application secret, so these are hard coded into this STS. It's a sample secret token service built with the Spring Boot. And then I'm getting this on behalf of a user. So I'm using password grant type here. Once again, ideally you should not use password grant type. You can pick the OAuth grant type based on your application. Yes, so that's what I do. So let's copy this one. Okay, so one more thing. So this is using port environment variable. So I need to use the node port here. Let's export this here. Okay. Now if I execute this one, it should return me a JOT token. Yeah. So this is the OAuth response, the OAuth access token, which is also a JOT token. So if I copy this and if you go to jwt.io, you should be able to decode this one, right? You can see the subject is Peter, and it has the audience strict.ecom.com, and it has this particular user has this particular role, and the scope is who. Right? Now I can use this JOT to access the order processing service. Right? So if you go to the slides, so this is a curl command to that. I need to export this token jot as token environment variable. And I need to copy the port, node port of the order service. Now I can use this curl command. Okay, so now you got a response from the order service, order processing microservice, right? Let's see if I don't send the jot, right? Ideally, it should still work because in this particular sample, we haven't done any security checks, right? So whether you send a token or not will just work. Okay. Yeah, still works because we don't do any security enforcement at the order processing microservice. This is just a plain deployment of the service, no security enforcement, right? And I can see whether the other request works too. Here I'm doing a post to the order processing microservice, right? So this is the poll. You do a post, and then order processing microservice will do another post to the inventory microservice, right? No security enforced. Okay. So it works too. You get a 201 created. You don't get any like response back. Okay, so if you want to see the response of the inventory microservice, ideally you should print the item numbers. So you can do inventory. Okay. So this will show the logs from the inventory microservice. Now if I write again, so you should see these item numbers, right? So these are the item numbers we pass from the curl, then to the order processing microservice, then order processing microservice pass the same item numbers to inventory microservice so that it can update its inventory. Okay. So that's the basic setup with no security. Now let's see how to keep improving this one. Okay. So this is actually what you saw. So you have the load balancer. In this particular setup, there's no load balancer. You have the STS microservice, order processing microservice, inventory microservice, all running as Kubernetes pods, and there's a proxy, envoy proxy running along with each microservice. Here from the curl client, I am doing HTTP client and HTTP request, not HTTPS. So it goes to the Kubernetes environment and hits the proxy, and then proxy will dispatch to the STS microservice. Same happens here. All HTTP, no security enforcement in this particular case. Right? Now let's see how to improve this scenario. First, we need to enable. First, we need to enable a TLS at the Istio ingress gate, right? So then we can send HTTPS traffic. Then we need to enable MTLS between Istio ingress gateway and the proxy, and also between proxy server, okay, or the envoy proxy. Okay, there's a question. Can you explain the sidecar? Yes. So when it comes to a Kubernetes, so you have the pod. So pod is the smallest deployment unit in a Kubernetes deployment. So ideally, you will have a single microservice or a main microservice running in the pod. So that we call main car. Then in addition to that, you can run other services in the same pod. Those we call as sidecars, right? For example, if your microservice, which is the main microservice, main car, it writes logs to a log file, right? So now we need to read or pass this log file and push this log to a centralized log server. So we don't need our business logic to do that. We can run another container in the same pod, which is simply pass these logs and push the logs to a central log server. So we call that a sidecar. So sidecar is co-located with the main car. So the proxy itself is also a sidecar. The difference between a normal sidecar and a proxy is all the requests coming to a port will go through or must go through the proxy. So that is done through by updating the IP tables of that particular machine, right? So proxy is a sidecar, but a special sidecar because it intercepts all the requests. Okay. So now let's see how to enable TLS at the Istio Ingress gateway. Okay. So once again, we are reaching the same diagram we saw before. So this is the Ingress proxy. Now we need to enable TLS here. To do that, we need to generate a private key and a public key and create a Kubernetes secret, right? Then in Istio, it uses SDS or secret discovery service to create this secret value. So first we need to enable SDS in our Istio deployment. Right? So I'll copy this command. Okay. So then it will write the updated configuration to Istio Ingress gateway file, and now I need to apply this one. Okay, done. Now I need to create a public private key pair. I'm using OpenSSL. So you don't need to set it up in your machine. I'm using an OpenSSL container here. Okay. Now I'll generate a key pair. So you can see the CN is set to gateway.ecom.com. So ideally, you can create credentials for each of your microservices based on how you want to expose them to the outside world. So in this particular case, so I'm following a bit of like lazy approach. Ideally, you should have one credential for STS, like sts.ecom.com, then orders.ecom.com likewise, right? Okay, so now generated certificates. Now, if you look at the file system here under gateway keys, you can see the public and private keys. Now, I need to create a Kubernetes secret with these keys. Okay, so here I give the name as ecom credential. Okay, done. So we got the credentials created. So the next step is, so now we have the credentials to secure the communication with our Ingress gateway with TLS. Now we need to create a gateway resource, right? So this is Istio resource, a gateway resource to instruct the Ingress gateway to pick these credentials if any requests come into this particular port for this particular host, right? Ideally, so in this case, once again, I'm following a lazy approach. So I'm creating a gateway resource for all the host names, right? So ideally, you can have different gateway resources or same gateway resource, but you can have different servers here by host name, right? So you can have one for sts.ecom.com, another one for orders.ecom.com, and then you can specify credential name, corresponding credential name under each host name, right? So I have specified here the ecom credential name here. That's what I created before. So now let's create the gateway resource. So this creates Istio gateway resource, right? So this will instruct Istio Ingress gateway to enable TLS with these credentials if any request coming to this particular port and this particular host, right? Okay, so next we need to create a set of virtual services for our microservices. Now in Kubernetes, we have created a service, Kubernetes service for each microservice. So STS has its own service, Order Processing microservice has its own Kubernetes service, then Inventory microservice has its own Kubernetes service. Now the virtual service will instruct the Istio Ingress gateway to route traffic from there to the Kubernetes service, right? Because if you look at this gateway, it doesn't have any reference to the service, right? And another thing I forgot to mention, the selector here, Istio ingress gateway. That means, so when you have the Istio ingress gateway label here, the selector here, the ingress gateway will automatically pick this gateway resource, right? When a request comes to this port and the host. Now, when you create virtual services, right? When you create virtual services, you need to create one for the STS, another one for the order service. We don't need to create a virtual service for the inventory microservice because we are not going to expose it outside the Kubernetes environment. Now, so here you can see this is attached to the gateway we created, right? So if you look at the gateway's element here, so this refers the gateway, right? So now through this, ingress gateway gets to know about our service, right? So let's create these two virtual services. Another element here, on a destination, this first points to the corresponding Kubernetes service. Okay, so now we got our two virtual services created. Okay, so the next one is here. So now we haven't yet enabled MTLS between workloads. Right? From Istio 1.5 onwards, it enables MTLS by default out of the box. You don't need to do anything; it's enabled out of the box. But once again, it's permissive. So that means even though it's enabled, if you want to use HTTP to communicate between workloads, you can do that. But if you make that strict, then you can't use it. You can't use plain HTTP. You need to enable MTLS. So to do that, we define a peer authentication policy, which will set the MTLS mode to strict. Right. So this is something. This is a new CRD introduced since Istio 1.5. Before that, you're probably using like generic policies, right? So something like this, right? So here you can combine MTLS authentication and also JOT together. But with 1.5, with two new CRDs, peer authentication CRD and request authentication CRD, that's been decoupled. So that's been made much cleaner. So if you want to do MTLS validation, then you need to use the peer authentication CRD. If you want to do JWT validations, then you need to use request authentication CRD, right? So let's first create peer authentication CRD to enforce MTLS between workloads. So now we have MTLS enabled between workloads. Next, to enable JWT validation, so there are two parts in it. So one is request authentication CRD. It will define the criteria to validate a job, right? So it says issue should be this one, audience should be this one, and to validate the signature, this is where you pick your JSON web key, right? So this part itself is not just enough, right? So if you just put the request authentication resource, still a client can send a request without a job and hit the service, right? It won't stop it, right? So if you want to stop it, then you also need to put an authorization policy. So this authorization policy simply says you cannot access this service without a job, right? So that is what this does, right? But if the JOT validation fails, like so you send a JOT, but it's not a valid JOT, so then it will fail at this level, right? So this is something new introduced in Istio 1.5. So authorization policy, once again, we'll talk in detail in later slides. Okay, so let's enforce request authentication. Okay, so done. So we'll skip this one. So this is a old way of doing that. Now we have our deployment like this, right? So you can send a HTTPS request and HTTP request will go through the Istio ingress gateway, and then the communication between ingress gateway and the proxy, that's protected with MTLS, and also communication between the order processing microservice and inventory microservice, that's also protected with MTLS, and you send a JOT, and JOT once again validated here, right? So now we enforce JOT validation as well. Let's check this one. So if you go here, so now you can see, so we are using HTTPS endpoints, right? So earlier we used HTTP endpoints. Now to find out the ports of the Istio ingress gateway, you can list out the services, and it's running on Istio system namespace. So this is Istio ingress gateway. Now you can like recall our gateway resource is bound to Istio ingress gateway, and our virtual services corresponding to each microservice is bound to the gateway resource, right? So this is of load balancer type, and so I'm running like Kubernetes on like Docker here, right? On my local machine, right? So it's a one node Kubernetes cluster. Here you can use 443 as the port, right, to reach the Istio ingress gateway. So let's export this as port. Okay. So now if I copy this curl command, it is HTTPS. Yeah. Now I got a JOT token here. Now let's export this one. And let's call the order service. Okay, so you got a response back, right? So this is so we have MTLS enabled, and also this does JWT validation. So if I try to send some invalid JOT, ideally this should fail. Right, so it fails, it says access denied, right? Okay, we can do this one too, to do a post. Okay, it succeeds as well. And if you look at this one, you can see the item numbers printed on the in-print microservice. And we can also look at the debug level logs of the Envoy proxy running with the order processing microservice. So then you can see how the MTLS validation is done, and also the JOT validation is done. And let's print the logs here. Order processing. And we need to connect to the Istio proxy container here. That's the sidecar. Okay. Now, if I run this command again, let's do it token, a valid one. If you look at the debug level logs, so this does the JOT validation, passes everything in our JOT. So this is the JOT we are sending, right? And it extracts out certain parameters, right? And it assigns the principal of the JOT, subject of the JOT to this one, request.auth.principal. That's the subject parameter from the JOT token, and this is the issuer slash subject, right? And we also use MTLS, right? So this is the service principal is picked from the client certificate, right? This is picked from the client certificate. Okay, this is basically the service account associated with the ingress gateway, Istio ingress gateway. Okay, so now, okay, so we have done this one. So now let's see how to enforce more fine-grained access control. Here we define authorization policy. So once again, the authorization policy was introduced since Istio 1.4. Before that, you may recall, like if you use the role RBAC with Istio, you might have used this service role binding, then cluster RBAC policy, those stuff, right? But now all those are deprecated, and from Istio 1.6 onwards, those will be removed. So you should use authorization policy if you want to do any RBAC validation for your microservice in the Istio deployment. So this policy is applicable for the orders microservice. So that's done through a selector. And then this says you can only do a GET to this particular microservice when you have this is from the JOT token, right? Username has to be Peter, scope should be foo, and you should also have the role user, right? So then only you can access this microservice. So this is a decoded JOT, right? So you can see the username is Peter. So you can put any claim from the JOT, right? Then the role is role user, and scope is foo. Right? So let's see how to apply this one. Here. Now we applied the policy. Let's try to invoke. So we don't need to talk to SPS. We already have a token. So let's try to invoke our order processing microservice with the JOT we already got. So it works fine, right? So that means it's a GET we are doing, right? And our JOT has all these claims in place. Now let's try to do the other one. This one is a post. Ideally, this shouldn't be allowed, right? Because we only allow GET. So this is doing a post to the order processing microservice. Okay, so this is, let's see, it takes some time to cache. Ideally, this should fail. Okay, now you can see it's access denied, right? So our policy is effective now. So you can do a GET, right? You can do a GET, but you can't do a post. Okay? So that's what we enforced here. And you can extend, like, so these policies are very powerful. You can define your own expressions too, like when you do a match between the values coming in the JOT and the values you specified in the policy. Okay, so that's what I plan to cover in this session. If you have any questions, we can discuss those now. And then please feel free to unmute and speak up too.
Can you go back to the original slide where you have the Istio as the, I think, control plane? Can you go back?
This one?
Yeah, I was just trying to understand here, right, in the Istio control plane. So we have to put everything, all our internal services also in this control plane. Can you explain that a little bit? This pilot, Citadel, and these are specific to Istio, or?
Yeah, these are specific to Istio, right? So when you install Istio, you will have the control plane, right? And when you deploy a pod, right? This proxy, you don't need to do anything. You don't need to even change your deployment manifest in Kubernetes, right? You just deploy it, but when you enable Istio injection, auto Istio injection, then Istio will inject this proxy to your pod. And also will modify the IP table. So that means all the requests coming to your service will first go through the proxy. Then this proxy will communicate with the control plane to get the policies.
So is this done by the Citadel?
Citadel does one part, like for example, like some configurations like routing logic. So these are provisioned to these proxies by pilot. Citadel will provision the certificates and keep rotating the certificates.
Okay. What if we have some of the services that we want to run them in the control plane? So Istio comes with this whole thing, right? So do we can they coexist in the whole deployment?
So why do we need to run a service in the control plane?
No, some of the you go back to original one. You mentioned that there is some security management server or something. The customer might have his own already built. Like they might already have developed some, right? Not this one. Yeah, here CMS or whatever.
Yes, yeah,
There could be some
you
specific
can
stuff
plug
that they
into
want to do.
the control plane. So let's say, for example, I have my own policy engine, right? So I have my own policy engine. So I run my own policy engine in the control plane. Like basically, if you look at these control plane components, they are running in a specific namespace called Istio system, right? So
Okay.
you can have your own control plane and link to Istio control plane through a plugin. So if you have only a
Okay.
configuration point, you can write a mixer plugin, and mixer plugin will talk to your service. Same for analytics. Like say,
Okay.
analytics will be pushed from the proxy to the control plane. Then if you want to take control over that in a custom manner, then you can write a plugin here and talk to your own service.
Okay. So basically, if you want to bring in any of your customized solutions for whatever the reason, you have to bring them by writing this custom plugin and bring them into the deployment so that it becomes a part of the ecosystem. Is that correct?
Yes. Yes.
Okay. Thank you.
Okay, so there's another question. Is it possible to configure Istio Ingress Gateway to send a request to internal STS to exchange client jot which is issued by? No. Okay. So there's a limitation here in Istio. So if you go back to our deployment here, this is a use case I implemented. So when this maybe I put diagram, right? So when a request comes to this proxy, right? This proxy, and it talks to the other microservice from the order processing microservice to the inventory microservice, I need to pass a jot, right? So I need to pass the same jot I got before from the gateway. So Istio doesn't have a way to do it in a configuration. I cannot tell Istio to do that. So what I have done in my code is I can from the microservice side, I can get access to the jot I got from the gateway or jot that has been validated by the proxy, right? Then I by hand from my code itself, I attach it to the other request going from order processing microservice to the inventory microservice. So this question is like if you want to connect to a different STS, so here so there's no direct connections, right? So it's always a trust validation. So what you do is you specify this JWKS endpoint in your jot, then this proxy which validates the JWT, which will talk to it and validate token. You don't need to have direct connection between the proxies and USTS. There's another question. Just if API gateway fills up the JOT token with auth claims and hitting Istio ingress, goes to service 1, call service 2, does JOT token auth claim pass to service 2? Okay, I think that I already answered, right? So by default, it doesn't get passed. It goes to the first proxy. It won't get passed to the second proxy when the first microservice talks to the second microservice. If you want to do that at the moment, as far as I know, you need to do it from the code itself. You need to extract the jot, which is validated from the proxy, then attach it to the request generated from your microservice.
Does Istio support the, let's say if there are many requests are coming and we need to have the streaming, like kind of like very high voluminous services, right? Does Istio support this kind of deployment as well?
So Istio
like if you have to have a Kafka or whatever. Yeah.
gRPC communication, I'm not quite sure like what level of streaming it supports.
Okay. So how about this Istio pricing? Is it like by user? Is it? It's not a free, right? It's not open.
So it's just open source project, so you can use it yourself. So like
okay.
is open source, but there are some vendors who are giving support.
Oh, okay. So what is the adoption of Istio nowadays? Is everybody picking up?
So it's becoming popular, right?
Okay.
So large scale deployments, I think Istio plays a key role. So we only discuss very few of the use cases, but it addresses multiple other use cases even beyond security. So it's becoming very popular, not just Istio. Istio is popular too, but there are other service mesh implementations as well, like Linkerd and
Okay.
implementations. Yeah. So service mesh is basically a pattern, and you can see multiple implementations.
So is there a is this been like tested everything on all the different clouds, or is
Yeah.
there a documentation? Okay.
Yes. Yeah. So if you, in GKE, I think in AWS, Azure, I think it's available.
Okay.
So there's a question. So there are two use cases where JWT with the user's identity, and second use case is more internal use case where microservice. No, still we use JWT in this particular case to propagate the user context between microservices. Right? The service communication is protected with MTLS. You pass the user context using a job. So if the second microservice wants to do any access control based on the user attributes, then it can use a job to do that. And there's a question, is recording available later? Yes. So I'll publish a recording today itself and share the link.
I think one question on the climbs, did you answer that? The JWT token claim is passed to service 2. I think.
I answered this one, yeah.
Oh, okay.
Okay. So that's a question available in your books. Okay. So I can share the discount codes, no problem at all. Okay, then thank you very much. So so we also have Slack channel. So this is a meetup group we are like building up for developers who are focusing on IAM. If you go to our meetup page, you will find a link to the invitation for that Slack channel. So please join there. And if you have any questions like any other things related to IAM and development, we can discuss there. Thank you very much for joining, and stay safe. Thank you.